So let's start with this. What is AI? So basically, if you will go by definition, AI is a very superficial software which actually handle all kind of possibilities that can be possible in any practical scenario. And after completion of all these kind of possibilities, it do all kind of coding and any case is not excluded from it. This is particular definition of AI. But in modern context, you can simplify it by the naming. AI is actually simulation of human intelligence in machines. Machine would start behaving like human beings and they would be able to execute any task independently basis on their past learnings. Clear?
Yeah.
Any question about that? There should be, I guess.
Yes. So how do they behave actually based on some data that they decides a pattern, or it means, how do we say that?
So this is actually a very good question. And if you will think about yourself, I would say think about yourself.
Yeah.
Okay. So how do you take decision?
Yeah. I mean,
Be it anything. For example, like very simple thing. You have to do dinner after 2 hours. How you are going to take this decision, whether you will do the dinner or not?
yeah, see, it's kind of a pattern, or kind of whether I'm hungry or not. It depends on many
Exactly.
factors actually.
Exactly. It is a kind of pattern. Actually, you even when you started your life, you even didn't know that if you are hungry, that your hunger would be subside by eating food, right?
Yeah.
But you now learn that pattern when you were infant, you were hungry, you started eating, and then you know that there is a sense of fulfillment, right?
Yeah.
You know, if you are like if you are feverish and you are eating something, then might be your body won't feel much good, and that's why you start skipping meal in fever, right?
Yeah.
So how did it came? It came out of data. You tried, there was a data, and you learned from data, and you gained experience, and now you know very well if you are going to do dinner after 2 hours or not, right?
Yes.
So basically, it's the pattern, and same happens with machine. Machine itself do not know anything. Machine was dumb, machine is dumb, and machine will always remain dumb. But what we have done, or what our data scientists have done, we have trained this machine on ample of data, a lot of data, beat anything. Okay. For example, very simple. I can start with very simple. May I know your domains so that I can give you an example based on your domain?
Uh, Currently we are on e-commerce domain.
E-commerce. Okay. Okay. Both of you are working in e-commerce, right?
Yeah.
Right.
Okay. So in e-commerce, there is a very simple pattern, I would say. When anyone is buying bread, okay, then there is a lot of chances that that same person is going to buy egg or butter, right?
Yeah, possibly. Yeah.
Exactly. So how we know this by, even we know this by data, and the same thing we are going to teach our model, or I would say our machine, using the data. What I will do, I will take the pattern of my last million orders. I would say that million orders, or maybe orders in lakh, actually at least 200,000 orders. Okay. And
Yeah.
then I'm going to pass that data into machine, and I will ask machine to learn the pattern. Then machine will automatically learn the pattern. If there are 20% order in which bread has been ordered, then out of that 20% order, at least 80% order had butter or egg with them. Okay. Then in my recommendation system, my AI model would learn that if anyone is going to order bread, then there is a high possibility that there would be subsequent order of egg and butter. That's why in recommendation portal or system, it will write down same products. For example, when you are working with Amazon and you are ordering something, then there are recommended products in the last, right? So same happens with this. If we are going to use AI, then same AI is going to use this data, train itself on data, and then going to recommend possible products for you. Got it?
Yeah. Right.
Now there's a very high disclaimer, I would say, or important disclaimer in this part. Machine learning model or AI always work on probability. Okay. So when it is recommending you when it is recommending you butter or egg with bread, it is never 100% sure that you are going to order that. But it is 70% sure, 80%. Actually, 70% is very good figure in AI or machine learning. So if it is like 70% sure, then maybe you are going to order this product, then it will recommend you that product based on its percentage, or I would say arrange it or sort it by percentage. Clear on that?
Mm, yeah, I'm
I would say again. So in machine learning model, probabilities are always derived whether this action can happen or not. Based on probability, if it is more than 70%, then system would recommend that yes, this product can be recommended with this item and maybe our customer is going to buy that. As simple as that. Okay.
okay.
For example, even right now, if I will ask you, are you going to do dinner at 9 p.m.? You will say, yes, most probably I'm going to do dinner. You cannot say that I will do dinner, right? There are a lot of possibilities which can go awry,
Yeah.
right? So same happens with machine learning model. Machine learning model learns with data, create a pattern, most probably a mathematical equation pattern. We will learn about it, but I'm trying to say that when we will get into detail. So basically try to create an equation, and by the equation, it creates a possibility scenario that this action can happen or not based on previous data. Okay. And you know the examples. Examples are like Siri. You must be using Siri or Alexa, at least one of that. Chatbots, ads in ChatGPT, self-driving car, right? In self-driving car, you can see that like in self-driving car, there are two possibilities or two layer of learning. One, to avoid collision. Second, to reach after distance. To avoid collision, we keep, for example, it is just an example, we will keep the possibilities at 95%. If there are even 5% chance that collision can occur, then machine or that computer fitted into the car would not take that action, would not take that road, or would not increase speed based on that. Got it? This is the firm learning, or I would say this is the rule that it happens, that it follow. And second possibilities, which is like 70% possibility scenario that this route is going to be good to reach that particular destination, and it goes via that. Clear?
Yeah.
Okay. Now, difference between AI, machine learning, and deep learning. Machine learning is, I would say, I would start with machine learning. Machine learning is very simple equation which is based out of data patterns that we have collected out of our source. Okay.
Okay.
And
Yeah.
what is, yes, question any?
No.
Okay. So, and deep learning. Deep learning is actually we like human brain work on neurons, right? You know that part. Each neuron is connected with each other via mesh network, kind of mesh networking. So same happens with neural networks. No one know how neural networks work. Even creator do not know how neural network works. But point is they have made a lot of decision points in the form of neural networks, and each decision points is actually connected with each other. So each decision, like each cell, I would say each decision point is connected to each other, and there are a lot of when any data is going on, and there are a lot of routing is going through via neurons, and a simple product, or I would say a final output, we get a final output in basis of 0 or 1 based on that particular neural network mesh network. Got it?
Okay.
And AI is like broad simulation of human intelligence. AI happens, it is based on deep learning only, but when we are training our data on very large subset, I would say that like billions of rows. For example, ChatGPT has 1.75 billions or 7 billions of row data strings, 7 billions of string. So if we are training our data on such a large subset, then we can say that we have created our deep learning model on very vast model, and there is a broad simulation of human intelligence, and we term it as an AI. Okay.
Okay.
Any questions?
No.
Okay, so before you came into this program, do you have any question, concern over AI or ML that you want me to cover? Or anything that you were excited about to learn into AI or ML?
It's work on any tool or something like how?
Okay, got it. Okay, actually, see, when you see the data, what do you gain? You gain experience, right?
Yeah, right.
Okay. And same happens with machine learning model. When we train the model on very large data, then they create models. Okay.
Yeah.
Now models are actually a file which had extension like PKL and all, but it is like let me see if I can give an example how it works. Actually, there are very limited tool which works on AI. Rather in backend, it is always going to be coding, Python coding. Okay, so I do not think there would be any tool that would be working for machine learning or AI in near future. But the application just like ChatGPT, Siri, Alexa are the best example who are working as a tool or application, which is using AI models for their task. But I can give you an example. There is a website named Hugging Face. Let me type it for you. After this class, you can actually go into this website and you will come to know how models are formed, how they can be downloaded, and how they can be used instantly without any previous training. So these are pre-made AI models, which is available as open source. You can actually download it, use some Python coding, and you can start actually using it in your daily task. Now, coming on to AI.
So in like Java, it's all about objects. So in AI, it's all about models. Is it?
Oh, no.
Okay.
In AI, it is all about data.
All about data. Okay.
Models are actually shortcut to data.
Okay.
Let me give you a good example. You can see this Nifty data.
Yes.
Okay. See, this is very simple Nifty data. I have date, open, high, low, and close. Okay. You can see that, right?
Yeah, right. Right.
Now, what I will do, just give me, I will, let's start actually, let me give you an example, a live example actually. I would give you a live demo how models are formed so that you are more clear how things works in Python. Just let me open my ID. On which ID you both of you have experience? Can you tell me?
Intelligent.
Yeah, IntelliJ Eclipse and
Yeah, I would be working with this ID. This is known as Spider. Okay, you can see that.
Yeah, right. Aman.
yes.
Okay. So we will see how simple machine learning model program look like in this now, and you will come to know how actually models are formed. What are models? Okay. So first of all, as we import libraries in Java, we are going to do same thing in Python. And then I would be copying that place. Give me a moment. See, pandas is the library which we use to read Excel file that we had, right? Got it?
Yeah, got it.
In first scenario, in first variable, we actually give the file path. I have already written file path, or I had already copied file path. And then in second column, we actually give sheet name, from which sheet we actually want to read that part. Okay. And by this method, we actually make our data as in memory. In memory is right term in Java, right?
Mm-hmm.
Actually, I don't have any very hands-on on Java, but I am working on Python only. So see, you can see our this data is in memory now. Now what we will do, we will try to make a program or a model based on this data. And we will try to predict if market is going to be upwards or downwards next day. Make sense to you?
Yeah.
Yeah, right, right.
Give me a minute. Okay. So first, to train any data, when we have the data, we actually split the data into two parts. One is training part, another one is testing part. Okay, same data, historical data only.
Okay.
Now, first of all, we will learn how to actually divide the data into two parts. And to divide the data into two parts, we actually do it by our data science library, very popularly known as sklearn or scikit. You know how variables are passed into Java?
Yeah,
You can return multiple variables by the function of Java, right?
yeah.
Okay. Same, this is the function name that we are going to actually split the data, and these are the four variable that will absorb the output that would be coming from this function. I will tell you what X and Y is. So see, uh, test size is something that we can control if we want to take 20% data for testing, or we want to take 10% data for testing. By test size, I will explain it to you. For example, we are having 100 rows of data. So we can actually split test size into 10% or 20%, and it's as per our requirement. And we do this so that we can actually check if the output or the model that we have created, we have created on primary data is working fine for prediction on test data. Do you understand what I'm trying to say by this line?
Create a primary data.
Not really, actually.
You can actually say no, because that will actually help me or motivate me to explain it.
No, that's what I'm telling. Not really.
Okay, see. First of all, understand why we use machine learning model or AI. Can you tell me why we use it?
Uh, to simplify the process, to simplify the work.
Simplify the process, right? Anything else?
Yeah, to reduce the time. To reduce the time of the work.
To make simple or to complex things like
Okay, simplifying the work. Got it. Now, may I ask you how you are going to simplify your process, how it is going to be done?
Yeah, like we have to analyze the past work, and based on that we have to like do the improvisation actually.
So exactly you have to improvise. Actually, you don't improvise, actually, you actually predict.
Yeah, predict. Yeah.
You have to actually predict the process, number, or possibility.
Yeah.
You are with me or not in this part? When you are simplifying anything, actually, you are trying to predict the possibility.
Yeah, kind of we are doing a trial and error actually. Yeah.
Agreed on this?
Yeah.
Yeah. What is
So
the process?
any machine learning model, I would say any machine learning model is used to predict the possibility or output. Now I will explain it this part. For example, I would go with dinner part only. This machine learning model, ML model, would have data that you have done dinner at 9, maybe dinner like on daily basis or not. Okay. This have this kind of data. How this data would look like? First column is going to be date. Second column is going to be whether you have done lunch or not.
Mm.
Third column is going to be evening snack, right?
Right.
And fourth decision can be you have fever or not. Fifth can be you are home or outside. Agree on that?
Yeah, yeah.
And then sixth part, we are actually going to see if you have done dinner or not. So for this part, for actual data, we will have yes or no, right?
Right.
But for the day, we have to predict we will not have this yes or no column or maybe a cell. We will not have this cell. You agree on that? Now let me explain this to you. For example, you are having this data for last 100 days.
Okay.
Okay. And then for 101st day, I will give you these 5 things. And then I will ask you, you have to predict that you are going to do dinner or maybe some person XYZ is going to do dinner today or not.
Okay.
Got it or not?
Yeah, yeah, yeah.
Yes.
So this is the basic crux of machine learning. Actually, we are going to predict something out of a data set. This is going to be first 100 days is going to be our data set.
So basically from where we collect these data actually.
That depends. See, you are working in e-commerce, right?
Yeah.
So you are having a lot of data, how consumer behaves, how consumer track or how
Mm.
consumer do orders, how consumer surf your website. If they are going from grocery to uh, cleaning supplies, they are going from cleaning supplies to grocery. You are having all these kind of data, right? From which
Mm.
category they are moving from one place to another. You are making user stories for this part, yes or no?
Yeah. So for the day-to-day customization based on the requirement needs, we have to gather the data.
Exactly. See, first of all, this is a fact. Like this is a biggest fact that ML or AI cannot be made if you do not have data.
Mm.
Okay. And this is the basic, or I would say this is the reason that why AI or ML is on boom from last 10 year only, because from last 10 year only, there is a burst in data. Previous to that, there was no internet, there was no records, there was no data. But from past 20 years, we are seeing that everybody is maintaining database, everybody is having data. That's why AI and ML came into picture afterwards. Got it?
Yeah.
So when I'm working with this kind of model, stock data, when I'm having this kind of data for past 5 or 7 years, okay, then I can use machine learning models for a next day to check if market is going to be up or down, or what value it at what value it can close at very next day. I can use this ML model based on this previous data set. Got it?
Yeah.
And now it would be divided into two parts. For this, let's say for this example, if you're going to do dinner or not, this part. First part is would be called features, and this part would be called as target, because we have to predict if the person has done dinner on next day or not. This is our target. Got it? We call it features label, basis on which we actually detect, or we actually try to find out the possibility that can be done next day. You are not clear on that? Let me get into. You can see this screen, like
Yeah,
Excel.
yes.
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 Okay. You can see this by date, open, high, low, or close. You can see this.
Yeah, those tabs, right?
See, in data set or data science, these columns name are can be termed as features or label of data. This is actually label of data. Okay. Date, open, high, low are going to be label of data.
The cursor is showing on the left side. Yeah. But result is on the right. The data not data.
I didn't get it.
No, actually you're moving cursor on the left side, but data is on right side, so we unable to match like.
Uh, I do not know what you are seeing, but can you see this column name like date, open, high, and low?
Yeah, it's the right side.
So this column name is known as labels or feature in data science. And what we are going to predict is known as target in data science. This is nothing to learn. This is just fact how data science works. Okay.
Yeah, right.
So there is nothing to learn actually. This is actually close itself is a label, but point is we are trying to detect, or this is our target to find the close value of next day. That's why this label become the target, and all other labels remain labels or features. Okay. You can see this screen, spider.
Yeah, right.
Okay. So this is how we are going to actually define our labels and target. See, uh, this is going to be our this is how sorry, yes. Devansh, you were saying something?
No,
Okay. Now I will tell you why we divide our data in two parts. First is test. Sorry, first is train. Next is going to be test. Okay. Now, for example, for the dinner example only, I have given you 100 days of data. Okay. and ask you to tell me if person ABC is going to have dinner or not. Right? This was our problem statement. You agree on that?
Yeah.
Now,
Yeah, right.
let's say you read about this 100 days of data, you gained some experience and you predicted that that person ABC is going to have dinner on 101 day or not. Okay. Then tell me, when will I come to know that your prediction was correct or not?
Through continuous testing.
Right. Continuous testing. Exactly. And according to you, if I want 70% efficiency, then after how many days you will be able to comment that your understanding is correct or not?
At least we have to test for 70-80 times minimum.
Exactly. 70-80 times. Or I would say you have to test at least 10%
Yeah.
more days. If I'm giving you 100 days of data, then
Mm.
you will check for 10 more days, right?
Yeah.
You agree on that completely or not?
Yeah.
So what we will do, we will actually split the data. Split the data. And what the split of the data means? It means, sorry, that for 100 days, you will learn or train yourself on data of 80 days. Got it?
Yeah.
And for next 20 days, you will predict the output, then matches with actual value, and then calculate what is your efficiency in determining correct output. You understand that or not?
Yeah. Yeah.
Right.
If you have any confusion, you can actually let me know.
Yeah, please continue.
Okay. So I'm deleting this part now. We have actually successfully divided the data now. In machine learning model, in ML models, there are a lot of pattern learning by which we can or we may reach to desired output. Now, what does it mean? It means that you can have any number of relation between features so that you can predict a correct target. Okay, that can be mathematical, that can be purely based on data. Got it?
Yeah. Yeah.
By mathematical, we mean simple linear, or I would say simple equations. Do you remember y equal to mx plus c?
Yeah, yeah. Linear.
Exactly, linear equation. So maybe this is the one who is actually, maybe this is the one which may actually fulfill you or which may actually help you to find out if person ABC is going to have dinner next day or not. Maybe this can also be true. By this we mean what we do actually, this is going to be x1, future 1 plus x2, future 2, and so on. Now maybe see, you have fixed value of feature. Do you agree on that?
Yes. Yes.
See, for example, date, open, high. Open and high is something which has been already given to you, and that is a fixed value, right?
Yeah.
So X1 and X2 is something that has to be determined. Y is target. And maybe X equal to 0.2, X2 equal to 0.003, X3 equal to 0.04, and maybe this work. If it works fine, we will try to test ML theory on training data and determine if that equation is suitable to find or predict output or not. Do you understand this part or not?
That formula, how did we, I mean, bring
Got
it out actually?
Okay, see. Do you remember how we used to find out value using hit and trial?
Yes, yes, yes.
Yeah.
So this
By putting random value. Yeah.
exactly, this is basically hidden trial methodology that machine learning model do in this particular model learning. We are having a lot of model training methods, but right now I am talking about linear regression model in which we actually use
Okay.
linear equation. In
Okay.
linear equation, see, this feature 1 and feature 2 are going to be fed from here. This is open value feature 1, this is feature 2, feature 3. These are fact. Do you agree on that?
Okay.
Now we will try to find out value x1, x2 for this and x3 for this, so that we can find a relation if there are some number which multiplied with these features can bring us to this value. And this happened proper hit and trial method. There is no sense in that, but machine try to find a basic x1, x2, x3 material which can actually fulfill this requirement. Okay. And now we have to understand that x1, x2, x3 are actually calculated for all the rows at one. Got it?
Yeah.
So this x1 and x2 and x3 are never going to be perfect. It try to find x1, x2, x3, which bring value closer to this target. It is not going to be 100% close. It can be 99% close. It can be 70% close, or maybe it is 10% close, or maybe it is just not working fine. It is 0% close. This is hard to learn. No issue. Let me give you an example. Give me a moment. Let me open an Excel file.
Yeah, apart from ID, nothing is visible to us actually. Only ID we are able to see.
Sorry?
Only spider ID we are able to see.
You can see this file now?
Yeah, now,
Now,
yeah.
See. Let's say this, and this are actually features that we had as a factor. Okay. This is something that we want to derive. Okay. And this is the equation. And we want to find a value here, which would satisfy all of the equation to its best. Now, what does it mean? For example, let's say 100, 10, 30. And here I have written 300. Okay. Now, what I will do, I will try to find a number using this into this plus this into this. Now let's say x1, x2, x3 came out to be 0.1. X2 came out to be something like 0.5, and it came out to be 3. Can you see if I'm making any mistake in here? Let me try again. But you ultimately know what I'm trying to do, right? What this equation mean, or I need to explain this equation also.
No, this is we are able to get it.
I'm putting $sign because by using $sign, actually, when I will extend this part, row number would not change. Okay. So this is what I wanted to derive. This is the target that I wanted to reach. Okay.
Okay.
But this is something that I was able to reach using that particular value of x1, x2, and x3. Now you can see that this value do not match with my target, right?
Yeah.
200.
There is difference, right? You can see that. You can see that clearly.
Yes. Yes.
Now, what my machine learning model will try to do, it will try to find the appropriate value for x1, x2, and x3 so that this difference can be minimized. It does not need to be 0, but it need to be minimized. It need to find a number which would minimize this difference.
Okay.
Got it?
Yeah.
So this is how machine learning model works. It works on probability. It does not work on 100% accuracy, because 100% accuracy in real scenario or real world scenario is impossible. But it try to find out number or middle way by which we can minimize the difference between two things. This is expected, and this is target, or I would say real value. Okay. Now you will ask me what is going to be benefit of this, right?
Yeah.
So benefit of this is going to be, for example, we have this data of 3 days and we want to predict the output for 4th day. And now this yellow part is fact. You know the real value of feature 1, feature 2, feature 3. Then we will, I would actually input that real value in this part. Now I will get the 253, right? This is the number.
Yeah.
Now, based on this value, I can tell you that this actual value is going to be between 175 to 275. This is how it helps.
Okay.
Got it?
Mm-hmm.
If you have any question, you can actually ask.
Mm-hmm.
Actually, this is going to be very useful for you if you can understand it. It does not matter if you are very much into deep learning in machine learning model or not, but if you can understand this part, what is the part or what is the actually requirement or what is the prediction value that we try to reach out of machine learning model, all over the things will become very easier for you. It does not matter you know the coding or not, but this is the understanding you need to generate to do the work in real time scenario or when you are doing job.
Mm-hmm.
Okay? So if you
So
have
you,
any question over there,
expected value you have put, so you means on your own, like just
these values or which value?
expected value, expected column.
Expected? No, no,
Yeah.
actually, I'm calculating it. See how I'm calculating this x1, x2, x3. Sorry, this cannot be visible, I guess. See, I have merged this column to make you understand this x1 value is going to be same for all rows. You understand this part?
Yeah, yeah.
Now, next part that you need to understand is like that this expected value is coming through x1 multiplied by feature 1,
Okay.
x2 multiplied by feature 2, x3 multiplied by feature 3, which is going to be this. Let me write it. x1 multiplied by feature 1, yes. x2 multiplied by feature 2 plus x3 multiplied by feature 3. Okay. In next row, what is going to happen? In next row, x1, or why should I write x1 actually? I should
So
write,
what is the value of x1?
just give me a minute. I should actually write x only. Maybe this is the reason you are getting confused.
No,
Oh, no, no. I have to actually,
no,
these are,
x1. You have to do
no,
x1.
actually, these are three x1, x2, x3. What I can
So
do, actually, I can write x, y, z. That would be easier for you.
yeah, yeah. So uh,
This is x, this is y, and this is z. Okay. Now in next column, f1, x is going to be same, feature is going to be second, y is going to be same, feature is going to be 2, and then z is going to be same, feature is going to be 3.
so my question is, what is the value of x1?
Okay, see. Let's say it x, y, z actually for the sake of easiness, y and z. No, are actually these are calculated value which are calculated on basis of hit and trial method, and we try to achieve an value to which we will have minimum difference between expected and target value. And this is not visible. Let me merge it. Wrap text. Let me increase it. See, this is XYZ. It became more clear to you or not right now? XYZ are actually calculated value, which is calculated on basis of hit and trial method. Okay.
Yeah, right.
And we try to find out a value so that this hit and trial by this hit and trial method, so that difference between expected value or target value become minimal. Or I would say calculated value, actually, not expected value. This is the fact value, calculated value. And we are deriving this calculated value using X, Y, Z.
Yeah, got it, got it. This one.
Got it?
Yeah.
This is actually crux of machine learning. If you understand this part, then you will clear all the machine learning models in one go. Now you have to see that we do not expect calculated value and target value to be 100% true, because it cannot be true. I can find XYZ value for this particular row that it will match exactly with 200, right? I can do that using maths, right?
Yeah, right.
But if I will use that value, then maybe this 300 difference would become very large. Maybe instead of 173, it will become 173, maybe, right? Which do not make any sense. So we try to find a middle path. We try to find or derive value XYZ in such a way that difference between these three and these three are minimal. And this is the crux of machine learning model. This is how machine learning model works. I do understand there can be confusion, so you can actually ask your questions.
I'm able to catch a bit of it actually.
Sorry.
No, I'm able to catch a bit of it actually.
Okay. And what about you, Devesh? Sorry, Devesh, yes.
Yeah, I'm
Okay, so clear on that?
yeah, clear.
If you are clear on that, then our rest of life is going to be very easier now. Okay. You can see the spider, right?
Yeah. A spider not able to see Excel.
You can see it right now.
Yeah, no.
Okay. Now see, we have already done this part. We have split our data into training and testing. Now what we will do, we will try to uh, find a machine learning model that works perfectly on this kind of data. So we will use same library, which is scikit library. And we will try to use linear model of this library. And this is how this coding works. There is nothing to learn. You can actually just what I would say, you have to actually accept it. It is just how it works. There's nothing more than it. You just know how to use it. And there are very limited number of code or wording that we use to get our task done. Once you know how to do, what to do, sorry, once you know what to do, how to do is not a bigger part. Now, this is all. By this method, actually, I have already trained my model. My model is trained now. Now I will show how to see what prediction model is giving.
So test side we have given 0.2, so we are training only 20% data, right?
We are actually, this is test size. So
Mhm.
training size would become 0.8.
So we are training 80% data.
Yes.
Okay. So whatever the value we are giving, so left will be trained, right? Left data.
Exactly. Exactly.
Okay.
If you want to train on 10% of data, then you have to do test size equal to 0.9.
Oh, okay.
But usually as per industry standard, we go by 80-20.
Okay.
Now, can you tell me what this line would do as per your understanding? See, I have this model which has been trained.
Yeah.
Let me write it like linear regression. This is the model that I have trained. Now, as per your understanding, what this line would do?
this we are trying to predict on that model by passing x underscore test. This x underscore test variable.
You are going on very right path actually.
So we are going to train 80% data. Test value 0.4.
Actually, see, we have already trained here, right? Our
Yeah.
training is completed
Yeah, training is
at
complete.
this part only. Above in this line, in 25th line, our training was completed. Okay. In 37th line, we are actually trying to find if our trained model, this is our trained model, model linear regression, right? We are
Yeah, right.
test how our trained model worked on our testing data. This is our testing data, X text.
Yes.
Right?
Yeah.
And once this is done, then you can actually print out the value of Y prediction. And compare with actual Y target, sorry, Y test values. If Y prediction was correct, not, or incorrect words. How close is like we actually do not expect it to work 100% correct. We just want to see how close this prediction value is going to be with actual value.
Yeah.
It should not have happened. Okay. Let me explain this thing to you. Actually, I'm typing out the prediction value. Now, what I will do, we have DF values. Let me explain this thing to you, what is happening. See, we will check if our prediction value is correct as per our testing data or not, right? So what is happening, the 20% data that we have saved for testing. Now, these are the value that is coming as output for that 20% of data. Now you can see 31568 is the value that is coming out of next closing value as per prediction.
Yeah.
These are actually value.
Yeah.
This is how data looks like. I can't help it.
Yeah.
You have to make sense out of it. So this is actually value for 20% of data, which machine learning model has predicted. Okay.
Yeah.
Now we can actually compare it with actual values and see if linear model is working fine. Now this comparison can be manual or automatic.
Mhm.
Okay.
Okay.
So automatic would make more sense in practicality for real world problems. You clear on that part or not? Till now?
Yeah, yes, yes.
And you asked me how or what model looks like. So this is actually linear regression model that we can actually save. We can save this as a file and I can send that file to you. Okay. Then
Okay.
what you can do, you can actually use that model to predict values at your end also.
Okay.
What you will do, you for example, at your end, you have a Excel file for which looks like this. Mm,
Just a curiosity, how we can do we have any another application where we can process this model to validate the data?
Actually, there are nowadays there are cloud application which in which you can see you have seen my Excel file, right?
Yeah, yeah.
There are cloud application in which you can actually get into the cloud. You can open that application. You can copy your data and you can select linear regression model. You can select these are the features, these are the target that I want to select, and you can process it afterwards.
Okay.
Got it?
Yeah.
But process is always going to be same. You always have to select features. You always have to select target, and then you always have to select on which model you want to process. There are three basic things that will remain same in coding, that would remain same in application.
Okay.
Okay. Now, as you will go on, you will come to know labels are all not always there. There are kind of data which is always unlabeled. There are data which do not make any sense. So by using machine learning model, we can make sense out of that. So once your basics are clear, each cloud platform gives you different kind of tools to process these kind of machine learning models. Once your basic are clear, it does not matter which tool that particular company is using. You can actually go and you can process the data using that tools easily. That is not going to be a situation.
Okay.
Okay. What I will do, I will try to give you a demo of Azure tools, how it works once we are completed through this. But I cannot actually commit you on that. I do not know if they allow you to give demo using free tier or not. And I'm definitely not going to show you my company portal. So I won't commit you on that, but whatever I will do, I can use some YouTube tutorials or I can say free tier allow me to showcase that tool to you. If it will be possible, I will give you demo of that once all of these things are done. Okay.
Okay. Okay.
So any question till now?
Yeah, I think we are good. It was first a good session actually.
If you have any question, there is a humble request of mine. Please note it down anywhere so that once we start next session, you can actually ask me those questions. The more you ask, the more you learn.
Yeah, of course, of course.
Okay.
Yeah.
So I would be closing today's session right now.